Hello everybody, welcome to YouTube channel Maths Insights. In this video, I am going to discuss very important problems based on LCM and HCF of numbers. The concept of LCM and HCF is discussed in the previous video. Based on that concept, these problems are going to be. Hence, I am advising all of you, please go through that video for better understanding and easy to solve these problems. So, shall we? This is the first problem. What this problem says that, what is the LCM of 8, 15, 24 and 72? LCM means least common multiple. You can find LCM in two methods. The first one is prime factorization method and the second one is division method. Generally, we are following division methods. So, you have to write these numbers in a row by separating with comma, and you have to prime factorize them. After completion of prime factorization, you have to multiply all those prime numbers, then that will be the LCM of. See, in my videos I will give most importance to the concept. If you know the concept very well, you can solve any type of problems, and also I will advise to approach the shorter manner also. Okay, now I am finding the LCM of these four numbers 8, 15, 24 and 72. The starting prime number is 2. If you observe, three numbers are divisible by 2, so I may start division with 2. Even though 15 is not divisible by 2, you can carry forward that. So 2 4s are, this is 15, 2 12s are and 2 36s are. Again, if you observe, you can divide all these numbers with 2 except this 15. Again, 2 2s are 4. Since 15 is not divisible exactly with 2, therefore I am writing 15. This is 2 6s are, this is 2 18s are. Now, if you observe again, these are again divisible by 2 except 15. 2 1s are, 15 is not divisible by 2. 2 3s are, 2 9s are. Now these three are exactly divisible by 3. Therefore I am dividing with the 3. So I am writing 1 as it is. 3 5s are, 15, 3 1s are, 3 3s are. If you observe, all these are prime numbers, therefore you have to multiply all these prime numbers to get the LCM of these four numbers. So 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 5s are 120 and 120 into 3, 120 into 3. See, this is 120 into 3. 12 3s are 36. So 36 is the LCM of all these four numbers. If you observe, every number 8, 15, 24 and 72 divides this number exactly. Shorter approach, technical manner. If you know the concept, if you know the properties of this LCM and HCF, it is very easy. See, when you are writing these numbers 88, 15, 24, 72, you are finding the prime factors which will divide these numbers. But when you observe, this 8 is containing in this 72. That means 8 9s are 72. So 8 is in this number. Therefore, it is not necessary to carry forward with 8. Why? Because 8 is already representing in 72. You may do the prime factorization again. See, I will continue with 15, 24 and 72. So I will divide these three numbers with 3. 3 5s are 15, 3 8s are 24, 3 2s are 6 and 3 4s are. Again I will do with 2. So 5 is not exactly divisible by 2, therefore I am writing as it is. 2 4s are, 2 12s are. Again with 2. 5, 2 2s are, 2 6s are. Again with 2. 2 5s are, means I am writing 5 as it is. This is 2 1, 2 3. So if you observe, all these are prime numbers. Therefore 3 2s are 6, 6 2s are 12, 12 2s are 24, 24 5s are 120, 120 into 3 again 360. LCM of the given numbers are 360. What is the difference between this and this is we are deleting 8 here. Why? Because 8 is already representing in another number. 8 is a factor of another number in this group. If you find 15 also, suppose if they have been asked you for 120 also, 15 is this 120, therefore you cancel this 15, you discard this 15 and you will find LCM of these three numbers only. Okay, this is one of the shorter way, and you have to observe that there is other way to find LCM of these four numbers. See, LCM is always the bigger number among these numbers. If you observe, 72 is the bigger number among these numbers. So you have to take 72 as your LCM. If you take 72 as your LCM, then you have to verify whether these four numbers divides this number exactly or not. 72 is always divides 72 exactly. 24 will also divide 72 exactly. 8 will also divide 72 exactly. But this 15 will not divide. So the LCM will be the multiple of this 72 only. Okay? If we want to make it divisible multiple of this number with 15, so this number, the multiple of this number should contain 0 or 5 in its units place. If you observe 72 ones are, you will not get either 0 or 1 in units place. 72 ones are 72, 72 twos are also 2 twos are 4. So you are not getting either 0 or 5 to make it divisible by 15. So if you goes on, you will find that 72 into 5, 5 2s are 10, okay, 7 5s are 35, 36. So 36 is the 360 is the LCM of these 5 numbers. See, it will looks like somewhat lengthy, but it will work effectively if you practice more problems. I will take another problem and I will explain it by using these concepts, then it will become very clear to you. This is the second question. This says that find the LCM of 8, 12, 15. For understanding purpose, I am taking a very simple question. After understanding the concept, you may solve whatever the difficulty of the question. They are asking the LCM of 8, 12, 15. You may do this by using prime factorization also. See, I will write 8 as 2 cube. That means if you multiply 2 3 times, you will get 8. And also if you prime factorize 12, see, it can be 4 3s are, again 4 can be written as 2 square into 3 power 1. Okay, and 15, 3 5s are 15. In this case, they are asking LCM. You have to take a prime factor which is having highest power. If you observe, 2 cube is here, 2 square is here, you don't find the prime number 2, but you can write it as 2 power 0. Anything power 0 is 1 except 0 power 0. So for my convenience, I am writing 2 power 0 to make it common in every number. I am writing LCM is equals to, first prime factor is 2 and its highest power is 3, so 2 cube. Next, if you see 3 power 1, 3 power 1 here also, but you don't find 3 here, but I can write it as 3 power 0. Therefore 3 is the other prime number and its highest power is 1. Okay, and if you see 5 is there, you don't find 5 here, therefore you may write it 5 power 0, here also 5 power 0, here 5 power 1. Therefore 5 is the prime number and its highest power is 1, therefore 5 power 1. So the LCM is product of all these prime numbers with highest exponent, highest power. The name is least common, but you have to take highest power. 2 cube is 8 and 5 3 is 15. 15 8 is 120. So 120 is the LCM of these three numbers. Now I will find LCM of these three numbers by using shorter approach. What I said, you may do it by division method also. I explained it by in the previous problem. Now I will take another approach. See what I said, LCM will be the either highest number in these three numbers or multiple of that highest number. If you observe, 15 is the highest number, you cannot find less than 15 which will become the LCM of these numbers. Okay, so if you take 15, you have to check whether the remaining numbers are divisible, divides this number exactly or not. It is very clear, 8 will not divides exactly and 12 also. So to find the number which is exactly divisible by these two numbers, you have to find the multiples of 15 only. 15 ones are 15, 15 twos are 30, 15 threes are 45, 15 fours are 60. See, I am writing 15 fours are 60. If you observe, 60 is divisible by 15 and also 12 but not 8. So 60 is not the LCM of these three numbers and it will be the multiples of 60 only. So 62 is 120. So 120 is divisible by all the numbers 15, 12 and 8. So this method will become very easy when you solve different types of problems. This is the third question. Third question, they are asking the HCF of 24, 30 and 42. You can find HCF of any number of numbers, minimum 2, and there is no limit for maximum. But you have to follow the same methodology whatever you are approaching here. To find HCF of these three numbers, you may follow either prime factorization method or division method. After these two, I will say the shorter approach how to find HCF of these three numbers. See, it is easy to follow the division method. To find HCF of any two numbers, you may take any two numbers among these three numbers. I will take the first two numbers, that is 24 and 30, After selecting the two numbers, you have to divide the bigger number with smaller number. See, 30 is the bigger number and 24. You have to divide it. 24 ones are 24. 6 is the remainder. With this remainder, you have to divide this divisor again. You have to write this divisor here. 6 4s are 24. So remainder is 0. You have to continue this process until you get a remainder 0. Then wherever you are getting your remainder 0, then that divisor is the HCF of these two numbers. This is clearly explained in the previous video, and hence I am advising you, please go through that video for clear understanding. Therefore, HCF of 24, 30 is 6. Now I have to include 42 also in this group. Therefore, after finding HCF of these two numbers, I will find HCF of 6 and 42. Why? Because 6 is already representing on behalf of 24 and 30. Need not to require to write these numbers. Therefore, HCF of 6 and 42. I will follow the similar way which is followed earlier. 42, I am dividing the bigger number with smaller number. 6 sevens are 42. So you got 0 in the first step itself. Therefore, this divisor is the HCF of this 6 and 42. Therefore, this 6 will become the HCF of the three numbers. Therefore, HCF of 24, 30 and 42 is equals to 6. In this way, it is somewhat easy to find HCF of any number of numbers. Now, I will teach you, I will say you what is the shorter approach. See, the name HCF, highest common factor. The HCF will be the lowest number of these three numbers, and it will not be more than that number. If that number is not exactly divisible by the given numbers, that may be the factors of that number. Suppose I am taking 24, okay, 30 and 42. As I said in LCM may be the bigger number among the given numbers or multiple of that bigger number. Now here the HCF must be the lowest number. Suppose if you see 24 is the least one, but 24 will not divide the other two numbers. Therefore, you have to factorize this 24. See, 1 is factor to every number. So, 2 is also factor, 3 is also factor, 4 is also factor. Okay? Right. 6 is also factor. And 7 not 8 is also a factor of this one. 9, no, 10, 11, 12 and 24. These are the all factors of the smaller number 24. See, you have to find the least factor, highest factor which divides these remaining two numbers. Why? Because see, with 1 you can divide all these numbers, with 2 you can divide all these numbers, with 3 you can divide all these numbers, with 4 can you divide? You cannot divide. That is not a common one. If you observe, the common factors are 1, 2, 3, okay, 6. 6 is also. Why? Because 6 4s are 24, 6 5s are 30, 6 7s are. 8 is not. Okay. 12 is not, 24 is not. Then what is the highest common factor? 6. Therefore, HCF of these three numbers 24, 30 and 42 is equals to 6. This is the very easy way how to find HCF of the given numbers. And there is other approach also. See, the HCF, if you find the HCF of these three numbers, that will divide exactly the difference of these three numbers also. This is very important point. See, solving many number of problems is not important. If you know the concept very well, you can solve any number of problems, any type of problems very easily. That's why I am giving importance in teaching the concepts. See, if you observe 24, 30 and 42, 24, 30 and 42, you have to take the difference. See, the difference of first two is 6 and the difference of these two is 12. Okay, the difference of these two, that means 24 and 42, this is nothing but 18. Okay, the HCF of these three numbers will also the HCF of these three numbers. If you observe, among these three, 6 will divide all the numbers. 6 1s are 6, 6 2s are 12, 6 3s are 18. Therefore, 6 is our HCF. In this way also you can find HCF of any number of numbers. If you practice, these methods will work very fastly. Believe me and practice. This is the fourth problem. Find the HCF of 30, 42 and 135. For clear understanding, I am taking one more problem to find the HCF of the numbers. See, whatever the numbers may be, the method is same. What I said, by division method and prime factorization method. Now I am doing it in prime factorization method. Why? Because we didn't do that. See, 30 can be prime factorized as 2 into 15 and also 15 can be written as 3 into 5. Means the exponents of all these prime numbers are 1. 42. 42 can be written as 2 into 21, that is 2 into 3 into 7. So these are the product of prime numbers. Taking 135. See, 5 is the in units place, so it will divide exactly with 5. Therefore 5 into 5 2s are 5 7s are. Now 5 into 3 into 3 9s are. Otherwise you may directly write it into 5 into 3 cube. As we discussed, in finding HCF of any number of numbers, you have to prime factorize like this. After that, HCF is the product of prime factors with lowest degree, with lowest power. If you observe, 2 is here, okay, 2 is also here, but you could not find 2 here, but you can write it as 2 power 0. Therefore 2 power 0 is the common prime factor with lowest degree. Next, if you take 3 is there, 3 cube is the highest, but you have to take the lowest. So 3 power 1. And if you observe the next prime factor 5. See, 5 is here, but you don't find 5 here. So I will write 5 power 0. Similarly 7 power 0. So this is the HCF, means 2 power 0, 5 power 0, 7 power 0, all are ones. So 1 into 3, 3 is the HCF of these three numbers. Now we will go to shorter methods. How to find this? What I said, HCF will be either the lowest number among the given numbers or the common factors of that lowest number. If you take these three numbers 30, 42 and 135, HCF may be 30, not more than 30, definitely. Or if these three numbers are not divisible by 30, then you have to write the factors of 30, and among those factors you have to find the highest common factor. If you see, 30 can be having factors 1, 2, 3, okay, 5, 6 and 10, 15, 30. These are all factors of 30. If you observe, 1 is common factor of all these, 2 is not. Why? Because it will not divide 42. 3 is the common factor of all these, 5 is not. 6 is also not. 10 is also not. 15 is also not. 30 is also not. So you find only two common factors, 1 and 3. Among these three, between these three, which is the highest common factor? 3 is the common factor. Therefore 3 is the HCF of these three numbers. Very simple. And if you take the other approach, see, as I said previously, the HCF of these three numbers will also the HCF of difference of these three numbers. I am taking difference of these first two numbers, 12, these numbers. So 135 minus 42, 135 minus 42, this is 3 and this is 9, 93. And what is the difference of this? That is, so 135 minus 30, so this is 105. If you find HCF of these three numbers, it will become the same answer. So again I am dividing this, finding HCF of these three numbers. Suppose I am following the division method, okay, 12 7 ja 84, okay, this is 9. Again you have to divide 12 with 9 until you get remainder 0. 9 1s are 9, so 3 3s are 9, 0. So 3 is the HCF of 12 and 93. Then find HCF of 3 and 105. That will be the HCF of all the three numbers. Therefore for 3 and 105 I am dividing 105 with 3. 3 3s are 9, 1 3 5s are 15. So 3 is the HCF. This method will also works very well if you have to practice more number of problems. Then these concepts will become very clear and very easy. I find the LCM of 1 by 3, 2 by 9, 5 by 6 and 4 by 27. These are fractions. So far we solved problems of numbers, but here I am taking the problem to find the LCM of fractions. I clearly explained how to find the LCM of fractions. Very simple. LCM of, okay, you know, LCM of fractions is equals to LCM of numerators by HCF of denominators. Very simple. So you have to find LCM of 1, 2, 5 and 4. భావిక సౌండ్ చేయొద్దు అన్న. భావిక and HCF of 3, 9, 6, 27. You have to follow the same methodology as we followed in the previous problems to find LCM and HCF. Then that will be the answer for this problem. Now LCM of 1, 2, 5 and 4 is 1, 2, 4 and 4 is, see, you have to understand the concepts. LCM will be the 5 or multiple of 5. Okay, see, if you observe 5 is the number which is bigger among the given numbers. Okay, if you take 5 is not divisible by the other two numbers 2 and 4. Therefore you have to take multiples of 5. So 10 is divisible by 2 but not 4. So 20. See, after taking a number, you have to take double of that number. Don't take 15 again. Okay? So 20 is divisible by all these numbers 1, 2, 5 and 4. Therefore 20 is the LCM of these three numbers. Now HCF of 3, 9, 6, 27. What I said, HCF is the lowest, either lowest number among the given numbers or the common factor of that lowest number. If you observe, the lowest number is 3 and 3 divides all the other 3 numbers. 3 3s are 9, 3 2s are 6, 3 9s are 27. So 3 is your HCF, therefore 3. So LCM of these fractions is 20 by 3. In similar way, you can solve the problems to find the HCF of the given fractions. If you want to find the HCF of these fractions, it is very easy. HCF of numerators by LCM of denominators. So if you want to find HCF of these 1, 2, 5 and 4, you may follow the method whatever you like, very easy, and you may find that fraction which is HCF of these given fractions. Now I will take another problem. Find the LCM of 0.6, 9.6 and 0.12. See, I am taking here decimals. To find either LCM or HCF of the decimals, you have to take equal number of digits after the decimal. See, after the decimal you have 6 only, you may write 0 also. Why? Because after decimal there is no value for 0, you may write any number of zeros. And this is 9.60 and 0.12. See, 1 2 is already there, two digits are there. After decimals 2 digits, here also 2 digits, here also 2 digits. So after adjusting, after making like this, you have to find the LCM of these three numbers 960, 12. Then see, writing 0 is not required. Find the LCM of these three numbers, then that will be the LCM of those the original numbers. I will adjust like that. If you observe, LCM of these three numbers must be the either the biggest number among these three numbers or the multiple of that number. The biggest number is 960. It's very clear. 960 is divisible by all these three numbers. Therefore 960 is the LCM of this 60, 960 and 12. So we have to place the decimal after 2. Why? Because you adjust it, you make equal digits after decimal, those are 2. Here also you have to make 2. So 9.6 is the LCM of these 0.6, 9.6 and 0.12. This is the same way how to find HCF of the decimals also. This is the next problem. I am taking the problem based on decimals to make it very clear. And if you observe, after a decimal you have 2 digits. Here is 1, here is 3. So these are the highest. So you have to adjust every number by writing 3 digits after the decimal. So this is 0.100 and this is 0.125. Now you have to find the LCM of 250. Forget the decimal now. 100 and 125. If you find LCM of these 3 numbers, then problem is over. As I said, the LCM of any group of numbers is the highest, either highest of that group or the multiples of that number. 250 is the highest. 250, if you take 250 as your LCM, but this 100 will not divide this 250 exactly. 125 will divide. So to make divisible by 100 also, you have to take multiples of 250. So second multiple of 250, that means 250 into 2 is 500. 500 will divide 250, 100. You have to check 125. Whether it is divisible, whether it divides 500 or not. You have to check. You may check 125. So 125 5s are so 25 to 0. So 5 1s are 5 4s are. It will also divides. Therefore, the LCM of these 3 numbers is 500. Okay, but you have to place the decimal point after 3 digits from the right side. So 0.5 is the LCM of these 3 numbers. I am explaining the concepts very clearly. I am not solving many number of problems. If you understand the concept, you can solve any type of problem. Now I will take some more difficult problems in the next video, and I am requesting all of you, please subscribe the channel if you don't subscribe earlier, and don't forget to watch previous videos relating to this video. And next video I will make 3 parts in this problem solving based on LCM and HCF. This is the first part. I will make 2 more parts. I will discuss very important problems in those parts, and requesting you, don't forget to watch those videos also. You will meet in the next video. Until then, have a nice day. Thank you very much.